Hello everybody, this is the second video clip about the L'Hopital's rule. Okay, previously what we study is that if your limit as your x goes to c of the fractions, okay, f over g, it is in the indeterminate form 0 over 0 or infinity over infinity, then you can just simply evaluate this limit by using the derivative of the top and the derivative of the bottom separately and evaluate the limit of this fraction instead. Okay, and of course, I mean, if this limit still in this form, you can further using or applying L'Hopital's rule one more time, okay, to find the second derivative of the top and the second derivative of the bottom until you can determine that the limit goes to one real number or the limit on the right goes to either positive infinity or negative infinity. Okay, today we are going to go over some kind of more complicated example. Okay, for example, let's look at this one. Okay, of course, the first example, number 1, as your x goes to 0, okay, the square root goes to 1, and then this one goes to 0, so you have 1 minus 1, which is 0, of course, and then as your x goes to 0, this x squared goes to 0. So this is the indeterminate form 0 over 0. Okay, of course, I mean, if you use manipulation as you did previously on your first chapter, you can say that, hey, we can multiply by the conjugation of this of the one on the top, right? And then you do a cancellation of the factor, okay, of so-called polynomial, and then you are done. Okay, that can be done as well. However, as we told you that you are going to try to learn how to use a L'Hopital. So let's pretend that we are going to use a L'Hopital. Okay, so as your x goes to 0, okay, this fractions goes to 0 over 0, right? So we can simply apply a L'Hopital at once. Okay, you do the derivative separately. The one on the top derivative becomes 1 over 2 square root of x plus 1. Okay, you know how to find a derivative of a square root, right? And then of course a derivative of 1, it is 0, and a derivative of x over 2, it is 1 over 2, and this one is 2x, right? This is 2x. Okay, so if your x goes to 0, still, you see, as your x goes to 0, this one becomes 1/2 minus 1/2, so it's still 0. And as your x go to 0 here, it also goes to 0 at the bottom. So this one, it is still in terms of indeterminate form 0 over 0. So it means that we may need to use the L'Hopital one more time. Okay, so what is the L'Hopital of this one? This one you need to look at it as what? 1 over 2 x plus 1 raised to the power negative 1/2. Okay, so a derivative becomes negative 1/4, and then x plus 1 raised to the power negative 3 over 2, and then the rest, they are constant, right? So the derivative goes to 0 immediately. So this one, derivative of your bottom, don't forget that we do it separately. You got a 2. So now, I mean, the x survive only here, okay, in your top. So as you plug in, your x goes to 0, this term goes to 1 immediately, right? And then so it means that on your top you got 1/4, and on your bottom you got just simply 2. So here you have negative 1/8 as your limit. Okay, as your limit. Okay, how about this one? This one, as your x goes to 0, okay, as your x goes to 0, your top is log of 1, so it is 0, of course. How about your bottom? Of course, I mean, x4 goes to 1 as well, so it is the indeterminate form 0 over 0. So let us use a L'Hopital one more time. I mean, just first time. Okay, so we have 1 over 1 plus x squared Of course, I mean, derivative of the inside, you got 2x, and then 4x cubed, okay, 4x cubed, okay, and then this is depends on how good your algebra is, okay. If you think that you are very good in algebra, then you can immediately look at it as a, you know, as a top over the bottom like this, okay, and then you find a derivative of your top and a derivative of your bottom, okay. You can go ahead and use it like that. Why is that we need to find further derivative? Because as you plug in your x goes to 0, your top still 0, your bottom is also 0, okay. However, I mean, to me, I'll do it this way instead. We are going to simplify it first. This one is actually the 2 and the 4 can cancel, okay, once. The x and the x cubed can cancel once. So actually your top is actually goes to 1, and your bottom is actually depends on 2x squared and 1 plus x squared. Is it right? This is a fraction manipulation. You end up with this simple fraction, 1 over 2x squared and then 1 plus x squared. And of course, I mean, the x, okay, it depends on the bottom alone, and as your x goes to 0, this one on the bottom is getting smaller and smaller. However, the one on the top is fixed to be 1. So 1 divided by a very, very small number, it will goes to a positive infinity. We know that it's positive because your x squared is positive and your 1 plus x squared is strictly positive, right? So it will be a positive infinity. So this limit, it is nothing but positive infinity, okay? The limit of log of 1 plus x squared over x fourth as your x goes to 0, okay? Look at some other example. For example, this one. If you need to evaluate this limit, of course, I mean, on the top, as your x goes to 0, x squared is 0. As your x goes to 0, your e to the 0, it is 1. So 1 minus 1, it is 0 again, and then this one is also another 0. So you have the indeterminate form, 0 over 0. So let us use L'Hopital right now. So on your top, you got a derivative of 2x. On your bottom, a derivative e to the x is 0 minus 1, okay. Okay, so don't forget the derivative separately. And again, as you plug in 0, your top is also 0, and your bottom, because your e to the 0 goes to 1 again, and then this 1 minus 1 is still a 0. So you need to use L'Hopital rule one more time. So as your x goes to 0, the derivative of your top is 2, derivative of your bottom is e to the x, okay, and then the rest will be 0. So now the x depends on your bottom alone. As you plug in your x equals, go approach 0, you have 2 over e raised to power 0, which is 1. So this limit is nothing but 2, okay. So as we told you, if the limit of fractions still in terms of indeterminate form, either 0 over 0 or infinity over infinity, we just simply apply a L'Hopital, okay, as much as you wish, okay, but it has to be in this form, in this indeterminate form, okay. How about this one? As your x goes to 1 from the right, okay, so let's look at a picture a little bit. Here is the 1, and your x goes to 1 from the right. So it means that on your bottom, it is 0, of course, right, because log of 1, it is 0, and then on your top is also 0, okay. So this one is if 0 over 0. So let us use a L'Hopital. Okay, let us use simply use a L'Hopital. So you find derivative of your top, 1 over x. Derivative of your bottom, it is 2x minus 1. and then as you see that you got, I mean, fractions over something, right? So you do a simplification first. So you have this fraction instead, right? So it is 1 over x and then 2x minus 1. Of course, I mean, now your x depends on the bottom alone. So here your x can be plugged in there. Okay, as you can see, your top is a fixed number 1, but then as your x goes to 1 from the right, okay, 1 from the right, this one goes to 1, of course, but this one goes to 0, okay, and of course it goes to 0 from the right as well. So what does this mean? It means that this limit, okay, it is depends on a fixed number on top and then a very, very small number at the bottom. So it goes to infinity. And we know that this infinity, it is a positive infinity because now your x is greater than 1. So it means that your x minus 1, it is greater than 0. So this factor, it is positive. And of course, I mean, this factor is already positive. So you have a positive infinity as your limit of log of x over x minus 1 square when your x goes to 1 from the right. Okay. We get. So let us continue further. Okay. Look at this one. I mean, it seems to be pretty difficult. However, as you look at it carefully, as your x pretty large, you have e raised to the power negative infinity. Of course, e to the power negative infinity, it goes to a small number. This one as well, it is a small number, goes to 0. So you got log of 1, which is 0 as well. So it means that, hey, we can apply a L'Hopital's rule immediately. So this one, as your x goes to infinity, okay, a derivative of your top, it is 1 over 1 plus e to the negative x. And don't forget a derivative of the inside, which is negative e to the negative x, right? Okay, and then this one, the derivative of a bottom is also negative e to the power negative x as well. Again, is a fractions over something, so we can do a manipulation first, right? We do a simplification first. So here you have 1 over 1 plus e to the negative x. Now, I mean, the x appears only at your bottom, and as your x goes to infinity, e raised to the power negative x goes to 0. So here you have this limit to be 1. Okay, very easy, right? Okay, let's continue further. Okay, on this example you got 2 problems. Okay, so again, this one, as we told you, that the logarithm of the x, okay, will goes to infinity as your x goes to infinity. So this one is actually the indeterminate form infinity over infinity. So we can use the L'Hopital right now. Okay, so this is the limit as your x goes to infinity of a derivative of the top, which is 1 over x, and a derivative of the bottom, which is 1. So this one is very simple because it is the limit of 1 over x as your x goes to infinity. So as you can see that now your top is fixed to be 1 and your bottom is getting larger and larger and larger. So 1 over a huge number, it will goes to 0. So it means that this limit, okay, the log of x over x as your x goes to infinity equals to a 0. How about the second problem here? Okay, as your x goes to infinity, your x squared will be pretty big number, and the same time as your x goes to infinity, the exponential raised to the power infinity will be a huge number. So this one is again the indeterminate form infinity over infinity. You can apply a L'Hopital at once. So the L'Hopital saying that you can find the limit of your derivative of the top and the derivative of the bottom. Don't forget that it will be e to the 2x, and then the derivative of the one inside, which is the derivative of 2x, right? So you can cancel the 2 and the 2 first, and you may say that, hey, this is still infinity over infinity, right? As your x goes to infinity, okay, and as your x goes to infinity to the exponential. So it means that you can use a L'Hopital one more time. So a L'Hopital apply to the top, okay, the derivative of the top will be 1, a derivative of the bottom will be 2, and multiply with e to the 2x, okay. So as your x goes to infinity, now it's easy because your x appear at the bottom alone. On the top it fixed to be 1, and on your bottom it keep getting larger and larger and larger. So the limit will goes to a 0, okay. Let's look at the last one, okay. The last one, if you want to try this limit as your x goes to infinity of x over a square root of 1 plus x squared. Of course, I mean, as you plug in your x goes to infinity, your top is infinity and your bottom is also a huge number. Taking a square root is still pretty large, okay. So this one, try to use a L'Hopital. So this limit, okay, it is 1 over a square root of, on your top a derivative is 1, on your bottom a derivative is 1 plus x squared, right, 2, and then a derivative of the inside, which is 2x, okay. And what you end up with, I mean, simplify a little bit, you have a square root of 1 plus x squared over x, right? Oh, what does this mean? Hey, it come to indeterminate form, infinity over infinity again, right? So let us try L'Hopital one more time. So as your x goes to infinity, the limit of your top, it is 1 over 2, a square root of 1 of 1 plus x squared, and then a derivative of the inside over a derivative of the bottom, which is 1. So as you manipulate, as you simplify it, you got x over a square root of 1 plus x squared. Is that look pretty familiar? This one with the original problem. So what does this mean? It simply means that there will be some problem, okay, some problems that a L'Hopital really cannot be used, okay. For example, this kind of problem, okay. Then how are we going to do it? Remember how we solve this problem, how we manipulate or evaluate this limit. Remember, actually we can just using the technique that we did previously, okay, by pull out the common factor, okay, the largest exponent of your x. So for example, this one, I mean, on top you have only x, right? But on your bottom you got two terms, 1 and your x squared. So the one that you are going to pull out, it is simply the x squared. So this one becomes 1 over x squared plus 1, okay. So it's look like you divide this thing inside by x squared, okay, then you pull it out. However, you need to be careful that a square root of x squared is actually the absolute value of x, okay. It is not simply an x, okay. However, right now your x goes to infinity, then you can take away the absolute value to get the x alone, okay. And then now your x on your top and on your bottom can be cancelled, okay, as a factor, because your x is a pretty huge number. So it is of course not a 0, so we can do a cancellation. So later on, the variable x appears only at the bottom, and as your x goes to a large number, you have 1 over, only this term, right? That is 1 over a large number, so this term goes to 0. So the limit will goes to 1 over a square root of 0 plus 1, which is 1. Okay, so don't forget that there'll be some problem, okay, that your L'Hopital cannot be used. Okay, for example, this one that we give it to you here, and then you may need to use your, the technique that you learned before to take care of this kind of problem. All right. Okay, so this is the end of this clip, and this is the end of the clip about the L'Hopital's rule. So we hope that you guys go over some of the exercise, okay, and we'll see you on the midterm exam. Bye bye.